Okay, for geometry, your lesson 8.5 is the law of sines. So find somewhere in this on this page to maybe come off to the side to actually write down what the law of sines is. I'm going to draw it out in a picture for you. So first of all, I want you to know that this can be used when we don't have a right triangle. It can be used when we do have a right triangle too, but a lot of times the law of sines is used when we don't have a right triangle. So I'm going to show you how to use it with other angle measures. So let's just say that this is triangle ABC, and the angle for A is down here, and the angle for B is up here, and the angle for C is up here, and I want you to use capital letters for the angles. And then the side across from angle A, so angle A's across, is going to be this side length, which I want you to use a little letter A for, a lowercase. So angle A is exactly across from side lowercase a. And then the same thing with B. Angle B is across from the side length that I want you to call little letter b, lowercase b. And then capital C's angle is across from its side length that is little c. So in this picture that is not a right triangle, and it's also not supposed to be an equilateral triangle, the ratio for the laws of sines would be sine angle A over lowercase a, which is a side A, is equal to sine B, capital B, that's the angle, over side B, and that's also equal to sine C over C. So that's the capital C, which is the angle, and the side length of C. So this is the law of sines. So this is the new formula that we're going to be using that I will write on the board to make sure that you guys know this, but that's what you're going to use in order to find either a missing angle measure or side length, depending on which one's missing. So I'm going to do a few of these with you, and then I'm going to have you do a few on your own. So we are looking for right now AC. So we're looking side length from A to C. They actually made their capital letters on the outside. I don't usually do that, but that's okay. We know what they're talking about. They're talking about side lowercase b. Oh yeah, they did. They did the angles or capitals. So if we're looking for side B, lowercase b, but we know that the angle of B is 22, and we also have the side C, which is 24, we could figure out the angle C because we know that all triangles add up to 180 degrees. So I would take 180 minus 118 minus 22 to get what angle C is. So let's take our calculator and do that first. So we have 180 minus 118 minus 22. Okay, and that leaves 40. So this angle C is 40 degrees. Now that we have a number and a missing number across from it, and a number and another number across from it, we can actually set up the bat and the ball. So we don't need to use all three of these. Since they're equal to each other in ratios, you can just use two of them to find a missing one, or the other two to find a missing one. So it doesn't matter which ones you use, they're all equal to each other in a ratio. So I'm going to set up sine 22 over b. So sine 22, that's sine capital B, over lowercase b that we don't know. That's what we're trying to find. And that's equal to sine 40 over 24. Sine 40 over 24. Okay, and all you're going to do is the bat and the ball. So you are going to multiply sine 22 times 24 and divide by sine 40, and that is going to give us our side length AC, which is representing B. So in your calculator, sine 22 times 24, and divide that answer. I'm just going to leave it on the screen. You could round it if you want to 9 and then divide that, but I'm just going to leave it on the screen. Divided by sine 40. So sine 40, I'm going to close my parentheses, equals about 13.99. I actually don't know what it wants us to round to. The nearest tenth. So 13.9. Actually, that's going to bump it up on it. So we'll call it just 14. So number one AC is about 14. Okay, let's try another one. So it wants us this time to find side length AB. So that would be across from angle C, so it's little letter C. And we know that that is the thing we're going to use, sine 53 over C, and we can set it up equal to sine 44 over 7 because we have that information too. So sine 53 over what we don't know, which is C, is equal to sine 44 over 7. Okay, again, the bat and the ball. So multiply the two diagonal and divide by the other one. So sine 53 times 7, sine 53 times 7, divided by sine 44. Sine of 44 degrees is about 8.0, so about 8. So we can say that our side length is 8. Okay, let's do another one. This one, it looks like we're going to actually have to find angle B because what we're looking for is BC, which is up here. So we're looking for little side A. And so we know that it's 39 degrees across from what we're looking for, but we don't have the angle measure to use sine C over C. So we can't use the 51. But we do have the side length across from B, so we're going to have to get B, and it's right now missing. So 51 and 39 actually add up to 90, so that means B is going to have to be a 90-degree angle. And you can still use the 90-degree angle. It's okay. We just had to solve for it first. So we're going to set up sine 90 over 27, and that's going to be equal to sine 39 over what we're looking for, A. Okay, the bat and the ball, multiply these, divide by sine 90. So sine of 39 times 27 equals, and then we're going to divide that by sine of 90. Sine of 90. And that is about 17. So 17 is side A, this side. All right, let's do another one. I think you probably get the hint, but I want to skip ahead. Don't stop listening until at least we get down to number 6, because this is when it switches to measure of angles instead of side length. And there's a little bit extra we have to do on that one. So let's just do one more of these, and then I promise we'll move on to number 6. Okay. So we're going to find AB this time. So that is across from angle C. So we're looking for a little measure C. And the only other one we know is 9 is across from angle A. So we're going to have to find what angle A is. So 101 plus 63 is 164. So 180 minus 164 leaves a tiny little 16-degree angle right here. Okay, so I'm going to set it up. Sine 16 over 9 is equal to sine 63 over C. All right, the bat and the ball, sine 63 times 9, and then divided by sine of 16 degrees equals about 0.3. So that does not look right, does it? Did I set that up right? Sine 16 over 9 equals sine 63 over C. I'm going to put it in my calculator one more time. Sine of 63, oh, I put 36. That's why. Sine 63 times 9 divided by sine of 16. Sorry, bear with me here. Sorry, did it again, double checked my work. It's important to double check your work. I got 29.1, which is much better. All right, 29.1. Sorry about that. Okay, I'm going to skip 5 for now because it's exactly like all the others we've done, and I want you to look at number 6. This time it has switched to now we're finding the angle of C. So this is what we're looking for. So I'm going to put sine 88 over 26 because those are two that we know. And I'm going to set that equal to sine C, which we don't know, so I'm just going to call it sine C over 21. Okay, the reason this is different, it starts off looking the same, so I'm just going to go ahead and do the bat and the ball. So sine 88 times 21, sine 88 times 21, and then I'm going to go ahead and divide it by my 26, divided by 26. Okay, here's the number you need to write down, but it's not the answer yet. 0.8072, really, I'm just going to write down 4 of these numbers just because as many as you can get will make it more accurate, but I'm not going to write down the whole screen. So 0.8072, so 0.8072. Okay, that is what this angle is without using the sine function. So now that we have to find the angle, we're actually going to use the inverse sine of this fraction. So I am going to click my shift button, my second, and then my sine button, because that is going to end up being the inverse sine. Okay, and it should look like this on your calculator. So inverse sine of 0.8072, 0.8072, close your parentheses, sorry that's a little too close, and it gives us an angle measure of 53.8. So the angle measure is about 53.8 degrees. Okay, so here's what you need to know. If you're looking for an angle, you do it the same way, but once you get it, you haven't used your sine function yet. So you need to do the inverse sine of your decimal to get the actual degrees of the angle. So let me do a couple more of these with you. Let's do 7. So we're looking for angle C. So sine C over 20 is equal to, we need to find 2 that we have. We have the A over the little a, so sine 82 over 29, sine 82 degrees over a 29 side length. So I'm going to cross multiply. I'm going to do 20 times sine 82, 20 times sine 82, and then I'm going to take that and I'm going to divide by 29. That's the ball. So divide by 29, which is, we're going to write down the number, or just remember 0.6829. 0.6829. So I need to put the inverse sine of 0.6829. So inverse sine 0.6829 is about a 43.1 degree angle. So 43.1 degrees is angle C. Okay, just for practice, I will do one more of these, but your practice is going to be to finish this page, but also to finish the whole next page. So they will be problems, sorry, you can't see that, problems 11 through 24. So you have to do 11 through 24 on your own. I will actually do this very last one with you. Let's skip down to 10 just for practice on one more of these. So we're looking for the measure of A. So sine A over 8, we don't know, so we'll do sine A over 8. And what we do know is 104 and 30. So sine 104 over 30. All right, so the bat and the ball would be 8 times sine 104. 8 times sine 104 equals a number that then I'm going to divide by 30. All right, so 0.2587 are numbers that we need to remember, and we're going to use the inverse sine of that decimal. So inverse sine of 0.2587 is about a 15 degree angle. So 15 degrees. All right, so your practice is 11 through 24 on the next page.